Welcome. Today I'm going to tell you something about versioning and packages in FHIR, which is a fairly new concept. I'm the architect of Simplifier.net and I'm co-author of the FHIR package specification. And so the first question that you might ask yourself is why packages and versioning in one talk? And that is because packages solve versioning, at least as good as they can, as good as it goes. If you look at normal resources in FHIR, and if you want to be certain that you point to a very unique resource around the world, so not in your local machine or wherever, but the whole world, you need 4 elements, and that's the FHIR server, a resource type, a version, and an ID and a version, because resources get updated, and you want the right version of that resource, and only then do you have the exact resource that you can be certain points to something invariable. In FHIR, there's a thing called Conformance Resources, and I'm assuming that everybody here knows what that is about. That's profiles. If you really don't know, let me know, so I can give a very short introduction. Okay, so conformance resources are identified by a canonical. But since profiles also get new versions, in order to get to the exact globally unique conformance resource, you will still need a version. And this is where it gets hairy. If you look at the top bit of XML, you see a reference to a profile with its version. And referencing to a version is very important often, but it's also very restrictive because you are specifying very precisely which version you need. And if for some reason there is a new version, or the server or the other system that you're talking to has a different version, then you have a problem because it won't match anymore. But the base point here is to declare a globally unique identifier for a conformance resource. You need a canonical, reference, and the version. So there are some problems here, and that's something that the FHIR community slowly starts to become more and more aware of, mainly because we start working with it more. And so the first part of my talk here is that we are going to look into those problems. So here's a bunch of canonicals, canonical references, canonical URLs. And these are, let's say, 3 generations. So in the first list, you have 4 canonicals that are all in version 1. And in case you didn't know, the pipe token in a canonical reference stands for I want that specific version of that profile. Now imagine that you update one profile, the patient profile, to a new version. And I marked it in red as 1.1. What you will see is if all the other profiles are very specific about the profile they reference, then you start to get a mismatch, because the allergy, the observation, the care plan, they all still point to patient 1.0. And so what you see here is that profiles don't live in isolation. So if you just update a version, stuff starts to break. And as a result, all the other profiles that reference to this profile need an update as well. Hence, we now have 4 profiles with version 1.1. But they don't contain an actual change. They're the same profiles, they just reference another version of the patient. So that's problem 1. Profiles don't live in isolation. Throughout this talk, I will talk about the term scope. And with scope, I mean a closed set of profiles that you can work with. That can be a use case, that can be a project, that can be an API. But the generic thing is the stuff that you work with without needing anything external. So, the second problem is that profiles usually go through a very rigorous process. You especially see that in governmental agencies and big companies, that there's a rigorous process of authoring, working out ideas, going to a draft, going to a procurement process, and then finally making the final version. The thing is, once your draft is good, the first thing you say about it is don't change it anymore. And of course, if the version is in the profile, the first thing you'll do is changing the version from a preview or a draft or whatever to a final version. That's the second problem. Problem 3 is that if you version individual profiles, you get all kinds of version mismatches. For example, if you have a diagnostic report pointing to patient 1.1 and a referral request pointing to patient 1.2, they can no longer work together. Let's take an example of a hospital and 2 general practitioner practices, and it doesn't really matter, but you can imagine that the hospital has an API that the GPs are connecting to. But it could be any similar situation. And so let's say that the hospital has a profile of patient, and we've given it h.org/patient as its canonical, and the 2 GPs use that profile and send resources to the server of the hospital that match that profile. At some point, the hospital will go to version 2. That's a natural process, and that's what you see everywhere. You see that happening in the FHIR standard itself. And so, if the GPs are still on version 1.1, they have a problem, right? And that's not a versioning problem in itself, but that's a general problem of upgrading. So the GPs have to upgrade, and the hospital cannot expect them to upgrade immediately, especially if they have a lot of consumers, a lot of external applications or institutes that connect to them. They will have to have a good upgrade path. So they will probably work with 2 profiles for a time, and how that works is, there's lots of ways to do that. It could be several APIs, or allowing multiple profiles, or multiple resources referring to different profiles. They have to have a period of upgrading. And so then you can see the situation where one GP can already work with 2.0, and the other still has to work with 1.1. But reality is that you don't work with one profile, but with a whole bunch. And the bigger the history become of a FHIR server and the change of business rules, the more complex your situation becomes. And as you can see here, this is no longer manageable. Except if you do a lot of work, which is in IT not good, right? You have to have a certain laziness to make things right. So, how do you organize this? The first thing you can do is be very specific, group stuff, but you still have all the problems of mismatches, upgrading issues. So the usual solution is that you start working with several APIs. So multiple FHIR servers, or a FHIR server that is very specific about its endpoints. But you have to have some organization so that you don't get all the weird mismatches, and that one client doesn't update versions from resources from different versions. Because as you see in API 1.2, there's a set of resources that are meant to be together, that have a meaning together. And this brought the people that work on the FHIR specification to the conclusion that in a lot of cases, it's very silly to version profiles, because what you actually want to do is version the API. Yet, if you bring the profiles to your consumers, you want to give them a version. And in FHIR, the current way of communicating that version is through a profile version. So we needed to have an alternative, and the alternative that we came up with is, why don't we package it up and make that a versioned scope? And that means that the profiles can have a version now, because it's still valid FHIR, but they don't need to, because within the scope, everybody understands what profiles reference other profiles. So that's the birth of packages, the thought. Now, packages is a concept that almost all developers know, and they have all got their own ecosystems and they work differently, but there are some core principles that are the same everywhere. The base thing that we want to achieve with packages is that we don't have to version the individual profiles, but we want to version the set of profiles, so the package. And what is a package? That could be a use case, it could be an API, it could be a standard. But in the end, it's a set of things that go together, hence I use the word scope. So the first question now is, what are packages in general? If you look at it very simply, you see it's a compressed file with other resources. That's how most people see a package. It's just a transport mechanism or something you can put on your hard disk. And it's a way of publication, because a file with content you can give to anyone. But packages are actually way more. It's also a promise, because packages usually live on servers where you can download them, and they have unique identification, and it's a promise that it will stay there. So if once you've published it, that everybody can use it without having to doubt whether it will be there tomorrow, or whether the content will be different, or whether the name will change. All that stuff will remain the same until eternity. And we all know what eternity means in IT, but so far packages have been the most stable form of that promise. Packages are also an ecosystem, because packages don't live in themselves, because you want to build on the work of others. The FHIR core is now, the FHIR core resource, the profiles, the Valuesets and everything around it is now a package as well. So if you start working with your stuff, you want to be very specific about what you build upon. So it's an ecosystem, and once you're done, other people can start using your work as well. Packages is also a very elaborate mechanism of communication. So imagine there's an author that builds a package. If he's done, he publishes it on a FHIR server, a package server. And once it's on the server, it can be consumed by a package client, which of course is being used by a tool or a user to use that package. And the best part is that you start being able to use the stuff you produce, or use the stuff that's produced by others, hence the circle. So for FHIR, this means that you can work with designing your profiles. When you're done, put them on a package server, and once it's on a package server, you could have a FHIR server that consumes those packages. They don't exist yet, but we expect they will. And so if you want to say, I have a FHIR server and I want to specifically define the use case, what's allowed on the server and what is not, you just say, download a package, make it work against the rules of that package, and that FHIR server enforces your business rules, enforces your use case. And once again, if you start building profiles, instead of searching the profiles anywhere on the internet, you can now go to a package server and be very precise about which profiles you want to use and from who and which version. So, what do FHIR packages solve? They solve a lot. The first one is maintenance. because the people that have been profiling since the beginning of FHIR, let's just say they had a lot of work and a lot of frustration in maintaining all the versions of the profiles. In the beginning, they didn't even use versions, but that was unmaintainable. And once they start using versions, well, there's a very small subset of people that really was able to maintain all the versions of all the profiles of larger use cases correctly. The second thing is the issue we mentioned earlier, is that it solves the cascading of updates. If I now update a patient profile, my dependencies no longer refer to the specific version of the patient, but they live in the same scope. Hence, everything will work without any change. And the third problem it solves, and that's something that I think all developers know, is version hell. So the second thing is, and that's what makes packages really powerful, is a very complete system of distribution. It helps. It has a system for publication, it has a system for distribution, it has a system for consumption, and it has a mechanism of communicating updates. This is something that all package systems have in common. The third one is communication, because if you have a use case, until now you could say my use case consists of patient 1.2, organization 1.3, etc., etc., etc. So it was just a large body of data, and now it has a name. Your use case has been given a name. And the fourth one is quality, because you don't have to do these weird updates to keep things working, and because things work automatically, there's a lot less errors. So I'll show you what packages look like in FHIR. The basis is that we designed FHIR packages to be conformant to the NPM spec. We've looked at several other specifications like NuGet or the Java implementations, but in the end we thought NPM is the most lightweight and broadly used system. It has its downsides as well, but it was the most easy and broadly used implementable standard. So there are four things I want to mention about what a package looks like. The first one is something I already said. It has a name. So HL7 FHIR core could be the name of the standard. In the end, we decided to put the FHIR version, not the resource or the profile versions, but the FHIR version behind it. So it's going to be HL7 FHIR core DSQ3 or R3 or R4, but it has a name. And we decided that these names should have dots, not because we like dots, but because we think that enforces you to think about scoping the logic of your name. So you're supposed to say the left part of the name is something about your country, or your company, or your region. And the second part is more about the use case or the actual content. And you can have as many dots as you want, but we decided to have at least one. The second part, of course, and that's trivial, but important to mention, a package has content. And we said a package in FHIR has a lot of resources. They're supposed to be in JSON format, and that's to make package consumption easier. They basically contain all the conformance resource of a use case. It can have other content, but we defined it to be something that can be ignored by any tool. So this is the enforced set. The third one, and maybe the most important one here, because that's the problem we wanted to solve, is that a package should have a version. And we just follow the NPM spec here. So packages use semantic versioning, also known as semver, and that's a standard on its own, which consists of 4 parts: the major, the minor, the patch, and optionally labels. And So that's what it will look if you put it together. So there's a package, demo, national patient care, and here's a set of possible versions that could exist on a package registry server. Inside there's one very important thing that always has to be there, and that is the manifest. It's a file called package.json, and it describes the package and its contents, and most importantly, the references. So here you see a dependency to HL7 FHIR core, and that means that if I build a package, whatever content it has, it also draws in HL7 FHIR core. So it basically draws in another package that becomes part of your scope, part of your use case. Dependencies are very vital to packages because you want to build on the work of others. And of course, you always want to build on the FHIR specification, so we've defined that every package should at least have a reference to HL7 core profile, so HL7 FHIR core R4, for example. But they can have reference to other use cases, and you will see that a lot, especially in larger companies that sort of have a central system of profiles that they want to be used throughout the company, and then there's more specific use case of departments, of devices, or whatever. Here's an example where two different packages could point or reference one common base set of profiles. And there's also that way a way to group use cases together, because a package doesn't actually have to have content other than the manifest. So you can say, I build a package called all. It has a manifest pointing to vaccination and observations and nothing more. So the package itself is empty, but the references are there. And that means if somebody installs that package, it will also draw in vaccination, observation, and patient care. So you can formulate a use case by just referencing a set of packages. That brings us back to the original problem that we had with profiles, because the version problem in its essence has never been solved. Versioning is hard. So, of course, at some point you will change your package. You will define new resources, you will change your business rules, and stuff will change, and you will publish it, and suddenly you will have a new version of your profiles. The main takeaway is that you now have one version to talk about instead of versions for every profile. And the nice part of it is that you can now upgrade parts of it. For example, if we don't upgrade observations, we keep it at 1.0, but we do upgrade patient care, then we don't have to upgrade observations, but maybe there's a change in vaccination, so that goes to 1.1 as well. And if we want to draw a new meta package, we will have to update that to 1.1 as well. But we can still use a large body of stuff that has not changed, the observations. And packages, especially in NPM, are very, very flexible in saying, well, I know I want this version, but I do want all the updates that become available automatically. Or you can say, okay, there's a specific package that we don't want to use, but all the others are okay. In FHIR, we've said we're not going to be that flexible, but we do want people to be able to work with minor upgrades. So we allow an X in the third number. And that means, as you can see now, that even though patient care has been updated, it does not necessarily mean that the packages above have to be updated, because they will just draw in the next version on installation. All right, so imagine there's packages on a server, which we call a package registry usually. How do you go about and install that? How does that work? For the beginning, there's a database or a file system where the packages live, the package repository. Then you have a server that exposes those packages to the outer world. So there's a very specifically defined protocol that a FHIR client can use to talk to a package server and say, I want this package with this version. Or I can say, can you give me a list of all the versions of this package? So this blue line here, this protocol has been very specifically defined and is very mature. And as a result, it becomes very easy to create a local system of your own registry, because you can install all the packages from the server theoretically, and usually a small subset, and you put that in your local cache. And in FHIR, we also defined a location where that is. It differs per operating system, because maps folders differ. But we have defined where they should live so that package clients can share the cache. And in that cache can live any number of packages you have installed over time, but you still need to define your own scope, and that could be one package or that could be more. And so that's why this box is here, where we say, I have a set of reference to certain packages, and that's the scope that I work with. And you can use any FHIR tool to work with that scope now. For example, a validator. So imagine there are 3 packages on a very small package registry: HL7 FHIR Core, US Core, and US Core Lab. These names are imaginary. They probably have a different name. And you see there's different versions available. Now, once I install a package, let's say I want to install US Core Lab 3.1, the first thing that a package client does is look in the local cache if it's available, if you have already downloaded it previously. And if that's not the case, it will go to the server and say, can you give me US Core Lab 3.1? The first thing it then does, install it in the package cache. And what a package client then does, in your local scope, add a reference to that package. And the package client has a way to get the content out of the cache without the tools having to worry about it. So all the tools should be able to work with the package client and just say, give me profile X. Now, it is interesting to realize that packages depend on each other, and that you therefore have to understand how the packages that it depends on are installed. So imagine that you, once again, install US Core Lab 3.1. Then what you want in your scope is US Core Lab 3.1 and HL7 FHIR Core 3.1, because that's the package that's being referenced in US Core Lab. So what happens is the package client will go to the server, or rather first go to the cache, see if US Core Lab is there. If not, go to the server, downloads it, installs it, then looks at all the references and installs those too. Then looks at all the references in those packages and installs those too, in as far as they are not yet in the cache. So in the end, you will have all the material you need by just adding one reference. All right. The state of affairs, where we are now. There's a lot of tools that have already implemented packages. To begin with, all the tooling of HL7 has already implemented packages. And my company built a command line tool that is free, where you can work with. We also have Simplifier, which is a complete package registry that you can work with and you can reference to. You can work with NPM, and NPM implements, I think, 90% of the FHIR package standard, but of course we have built some extensions, like we want a package registry to help me find a specific profile. So in a FHIR package registry, you can search for a canonical, and it will tell you which packages have that profile. An NPM server will not do that. Last but not least, the profile editor, Forge, also uses packages already, and that means that you can just say, you don't have to search for individual profiles or download them from the HL7 website. You can just now say on the screen, please install for me HL7 Core, and you will get the whole specification in your cache, and you can work with it. Tomorrow, there is a Let's Build session where you can actually learn how to install a package with various tools, which is done by Harthoorn, Wednesday at 11:05. This is the core of it, but there's lots more to tell, but I will leave that to depending on the questions you have.
So where is the registry? Is that under simplifier.net, or are you using it, the NPM registry, or multiple places? Or?
In theory, you can install a package to any registry that's there. Simplify has a registry called packages.simplify.net, and the tools like Torinox that you just saw will resolve that automatically. So you won't even know which package server you use, and then behind it, it's the package registry of Simplify. Same for Forge. And HL7 does not have a registry yet. We're now just posting stuff on GitHub, and we're talking about putting them on Simplifier as well, or maybe have a separate registry for the specification itself.
But so if I want to do a package, build a server right now,
yeah,
and I'm just going to use the core and US core resources and no custom profiles or anything, where do I get those?
There is a package on NuGet. I don't know from the top of my head where it is, but it is documented already on the specification. We also have a version of, I think, DSTU2 already on Simplifier, STU3. But in the next months, we're going to work very hard with HL7 to make sure that the package ecosystem comes alive. So it's now it's still a bit of a rough experience, and we only made sure that the pure necessary bits are there. So of course, the first thing you need is the specification itself, and we didn't want to take the name of HL7, so for now we put it online on Simplifier as Simplifier Core STU3 and Simplifier Core R4, but we're expecting to have the HL7 official packages on there as well in the next few weeks. If you, for example, install a package, if you start projects in Simplifier, you automatically, we now think of packages as the default. So if you start a new project, you automatically get a reference to Simplifier Core STU3 and in a few weeks to HL7 Core R3, whatever.
So when you build a new package, for example, and are using the dependencies, does that new package pretty much just kind of contain the deltas away from whatever that dependency was? Like if I was building a package based off of US Core, my real package would only kind of have the components that would be the deltas of that?
And
the changes?
I'm not sure what you mean, but it will contain the whole package, but of course your package will contain only what you should say that should be in there. So
Conformance resources that would provide the deltas away from US Core.
So you mean derived profiles?
Yes.
Yeah, so your package will contain the derived profiles, and we're still debating on whether a package should only contain the snapshots or should contain the complete snapshots or the differentials only. Currently, we haven't specified that. We're still talking about that, and that is a little bit because snapshot behavior still differs a little bit between the tooling. So you see that every tool generates its own snapshot. I think we'll go there that somewhere in the next year we'll decide that packages should have the snapshots.
Okay.
In theory, it's sufficient to exchange the delta, but then the server has to be smart enough to reconstruct the whole thing.
Okay.
Yeah.
It's just a matter of maturity. We're almost there.
And of course, you can have a sidestep. You don't have to have that. It's not necessary for every FHIR server to be able to be a package client and install the stuff itself. Of course, you can say, okay, I have some kind of tool where I install the packages locally and use another tool to upload it to my server to configure it. There are lots of ways to get the stuff there.
I got a mic. Hi, first off, thanks a lot for the talk. My question is about, you mentioned a couple of times that you have this cascading issue where you update the version of say an observation, and now all of a sudden the patient that has a reference to that observation also needs to get updated. Now, my understanding is that that's because of the canonical, which has this pipe delimited version string, but that's only introduced as of R4, if I'm not mistaken. So does this problem exist, in other ways beyond the canonical, for instance, in versions like STU3?
Well, the canonical versions have been retroactively fitted on STU3 as well.
Oh, really?
But sort of half official, because it was needed to solve some problems. What you see in practice is that most people that build servers and most people that create profiles don't deal with versioning at all, because it's too hard, it's too complex, too much work. So you see in most cases those references don't contain any versions. The thing is that you now don't know what your scope is.
And when you have something where you specify a reference type, is there any thought about allowing these kind of like wildcards, like say that I want a patient that meets version 3.1.x or something like that?
You mean in the canonical reference?
Yes. So
I don't, as far as...
or not necessarily the reference itself, but when you're specifying what types of references are allowed, for instance, in a structure definition.
I don't know, maybe you know that. But I think my basic problem is that you shouldn't.
Fair
and of course there are a limited set of use cases where it is very useful to version your canonicals, but it also creates a huge burden.
Okay, I think we're out of time, so...
I can give a 1-minute demo if you're interested, but
Well,
we actually ran out of time,
well,
so I don't know if you want to get the lunch.
Yeah, so tomorrow we have a session where we actually have some exercises and where you can consume and create packages, so to explore it, I would recommend joining us tomorrow.
Tomorrow at 11:05 you can actually work and experiment with it.
Well, thanks Martijn.